Hello, welcome to Linux Mate. Thank you for watching. This is part 2 of the introductory series on the C programming language for the GNU Linux platform. Today we'll pick up where we left off last week. If you haven't watched part 1 of this series, you'll find a link in the description to that. This time we will dive into variables, computer memory, input, output, and a few other things. So we have a lot to cover, so let's get started. At the end of the last video, I gave you a suggested homework assignment to write a program that displays some ASCII art on the screen. So before we go any further, let's take a quick look at a possible solution to that homework assignment. So I'm first going to start by pulling down the source code from the course Git repository. And I can do that using git clone and specifying the location of the Git repository on the GitHub site. So this will allow me to download it. And you can see now we have a GNU C tut directory. And there's a directory for lesson 1 and lesson 2. So let's go into lesson 1. And we have hello.c, which we did in the last video. We also have homework.c, which is the example homework project for the first video. So at the top, we just have some comments saying this is a sample solution for the homework assignment for video 1. And then it repeats the assignment. So write a program in C that displays some interesting ASCII art or text. And this example is pretty straightforward. The include statement includes standard input and output. And we need that at the top to use our printf statement. Then we come to our main function, which is the starting point of execution for any C program. The int indicates that once this function finishes executing, and since this is the only function, once the program finishes executing, it will return an integer value. In this case, it will return a value back to the operating system. The function's name here is main, and if we had any arguments or any parameters, we would put them here between these two parentheses. Then all of the executable code for the main function goes between these curly braces. And each of these statements is just a printf statement, and it's printing out Linux in some fancy ASCII characters. And one thing that I did want to mention in this file, it does have a few backslashes in this file. And since a backslash represents an escape character, or allows us to use special symbols, such as the backslash in, which gives you a new line. If you want to actually print the backslash character itself, you need to give it a double backslash. So basically, the escape character for an actual backslash being printed is 2 backslashes. Once we print all of our characters, all of our lines of ASCII art, of course ending each statement with a semicolon, we execute the return statement, which is returning 0. We have to return an integer because that's what we specified in line 10 that this function returns. And so let's have a quick look at what it looks like when we run it. So we will do cc for our compiler, and our source file is homework.c. The -o parameter allows us to specify an output file name, and I'm just going to call it homework. And now we can test the homework example. And as you can see, it nicely prints out the letters Linux in ASCII art. So that's the homework assignment. If you have any questions, please post down in the comments below. Before we jump into today's lesson, I'd like to provide a quick disclaimer for those of you who are familiar with programming tutorials in other languages. Many topics in C will require a deeper look and a better understanding of the internals than other programming languages such as Python or Java. As noted previously, C gives you more power and control, but in order to manage that power, it requires a better, deeper understanding of the concepts. The inner workings of things like computer memory, the manipulation of bits, and directly interacting with the operating system, while largely abstracted away in other programming languages, are cornerstones of C. This difference will be reflected in the way we cover topics in this course. So if it seems like that we're going slowly or focusing too much on minor details, just know that there is a good reason for this. So let's look at our first topic of the day, variables and data types. Variables are identifiers that allow us to access information in memory. So variables are the mechanism we use to store information away in the computer's memory so that we can retrieve it and use it later in our programs. Variables can store different types of data. The type of data that can be stored in a variable is called its data type. Popular programming data types, including in C, are integers, floats, and doubles. All variables must be declared and should also be initialized before being used. A variable's data type is explicitly specified at the time that it is declared and will not change. This is different from some other popular programming languages, such as Python and JavaScript, where variables are implicitly declared when they are first used. If you use a variable in C without declaring it, the program will fail to compile because it includes an unrecognized identifier. Thus, the compiler is unable to resolve it. If you use a variable without first initializing it, or giving it an initial value, you will get an unpredictable result because the assigned memory for the variable still contains whatever data was there previously prior to being allocated for your variable. So what exactly is your program's relationship to memory? First of all, before a program can be executed, it must be copied from disk into a location in the computer's memory. Since memory is allocated in what we call pages, which are of a fixed size and are mapped to virtual memory addresses, your program doesn't necessarily exist in a contiguous range of memory addresses, but since the underlying operating system provides us with virtual memory paging, it appears to our program that we have contiguous memory address space. A program is assigned several areas within memory for different purposes. There's the data section, which stores the values of any constants your program will use. For example, if your application uses pi in a calculation, the value of pi would be stored in the data section. There is the program instruction section, which contains the actual machine code that will be executed as part of your program. And then there's also dynamically allocated memory that you can request at runtime and use within your programs. When a new variable is declared, the operating system reserves memory equal to the size of the variable's maximum value and associates the address of this newly reserved memory with the name of the variable. When talking about using memory within your programs, it's important to understand that there are two types of memory. We're just going to briefly touch on them here for contextual purposes, but we will revisit the topic at a later time. The first type of memory is the stack. The stack is a small part of memory that is fast to access. Since it's both fast and a limited resource, it's usually used to store things that would benefit from being quick to access, or things that would be accessed frequently. The second type of memory is the heap. The heap is a much larger part of memory that can be dynamically allocated as needed, so meaning you can request it at runtime when you need it. but it is much slower to access than the stack. The heap is used to store larger, less frequently accessed data. C offers a great interface to allocate memory on the heap and to use it in your programs. For those of you brand new to computer science and programming, some of that may have seemed a bit incomprehensible, and that's okay. I'm introducing you to concepts now, so they will be a bit more familiar to you when we dive into them deeper later on. For those of you who are experienced programmers, you may have noticed that the whole topic of memory management has been extremely simplified. We will get to the core of these topics as needed during the duration of the course. So let's take a look at variable declarations and initialization. Variable declarations require two pieces of information. The first is the data type, and the second is the name. Initialization is done by assigning the variable an initial value. When a variable is declared, a memory address is assigned by the operating system to store this value. To illustrate declaring and initializing variables, let's take a look at the following. On the left, we have a table of values. The first column are some hypothetical memory addresses, and the second column shows the values associated with these addresses in binary form. Binary form is the way computers represent values internally. This is where the whole ones and zeros thing comes in. Fortunately, in C, we can work in base 10 numbers most of the time, so the compiler takes care of this conversion for us. On the right-hand side are a series of 3 statements in C. Let's step through them and see how each one affects the memory on the left. The first line of code declares a new variable of type int, or integer, and gave it the name x. Over on the left, you can see that memory address 0001 has been reserved to store the value of x, but that memory still contains the data it had stored previously. The second line initializes the value of x to the number 2. We declared x as an integer, so we can only assign integer values to it. As you can see, after x is set equal to 2, the value for memory address 0001 is now 00000010, which is the binary representation of the number 2. The third line both declares the variable y and initializes it to 5. It has been assigned the memory address 0002 and stores 00000101, which is the value 5 in binary. Okay, enough talk. Let's jump in and play with some variables. Let's create a new file, variables.c. And the first thing we need to do is to include standard input and output. You do that with the pound include preprocessor directive, which tells the compiler to include the header for standard input and output at the beginning of our program, which allows us to access everything that the standard input and output library offers for us. And the next thing we need to do is to create our main function. And now once we have that, we can create a variable. And remember, creating a variable has 2 steps to it. The first step is to declare the variable, and the second is to initialize it. And so we will first declare a new integer variable called x. So we'll int x. This tells C that we want a new variable of type int, and we're going to name it x. However, it's not initialized, even though it has been declared. So we would initialize it by giving it an initial value, in this case 2. We can also perform the declaration and initialization on the same line. So I can go int y equals 5, and this both declares y as an integer variable and assigns an initial value of 5. In addition to integer values, which are whole numbers, C also offers a decimal type, which is float. So we can declare a new float, and we're going to call it Z. And when we specify a float value, we need to specify F after the value to indicate that this is indeed a float. You can also declare multiple variables on the same line and initialize them. So if I wanted to create two integers, A and B, and initialize their value to 0, I could say int A equals 0 and B equals 0. And as you can see, both variables must be of the same type. And we could add more than 2 here. So we could say C equals 0. And we have created 3 integers, A, B, and C, and initialized them to a value of 0. Now that we have a basic idea of what variables are and how to use them, let's discuss the idea of input and output. A program can serve very little purpose without some way to accept input and generate output. We're going to look at 2 functions today that will allow us to perform basic input and output. So let's first understand what a function is. Functions are reusable blocks of code that perform a specific task or function. Functions can accept input as parameters. Once it finishes executing, it can return a value to the previous code. In programming, we say that we return a value to the calling function. All executable code in C must reside inside a function. We can use functions offered by the standard C library, functions written by other developers, and we can also write functions of our own. The 2 most fundamental concepts in computer programming are input and output. We need a way to be able to get information into and out of our program. So input refers to any data coming into your program from an external source. So an output refers to any data you need to send outside your program. Input devices include files, keyboards, mice, game controllers, scanners, networks, anything that brings data into your program. And output devices include monitors, printers, files, networks, etc. The first function we used in this course was the printf function. It allows us to print formatted text to the screen. It accepts a string of characters that can include special codes that begin with a %sign or a /. /n will give you a new line, /t gives you a tab, etc. If you want to print a /, you need to use 2 / in a row. The printf function also accepts additional parameters that allow you to place markers where you want values of variables to be printed. You indicate this with a %sign. %sign D means you want to print an integer, %sign F for floats, and %sign S for a string of characters. Here in the example, you can see that %S is used as a placeholder for the string called name, which is passed to printf as the second parameter. The second function we will look at is scanf. Scanf allows us to receive formatted input from the keyboard. It accepts a string specifying the format of the text to expect and a memory address to the location where this input should be stored. Putting an ampersand in front of a variable name will return its address or its pointer. We'll look much more at pointers later. In this example, scanf is expecting to receive 1 integer indicated by %d and will store the result it receives at the memory address of the number variable. And lastly, comments are text within your source code that do not execute. They're only there to serve as documentation for your code. So the better you comment your code, the easier it will be for you and others to read and modify later. Text enclosed in the /*/ characters will be considered comments and ignored by the GCC compiler. Also, anything after 2 backslashes will also be ignored as they represent inline comments. Okay, now let's take a look at generating some input and output in C. So now that we've got a basic understanding of simple input and output, let's see if we can combine our knowledge of variables and output and print these values to the screen. So as you can see, all the variables here are marked with or highlighted, and they're highlighted because they haven't been used yet, and that's not an error, it's just a warning. So the first thing I want to do is to print the values of x, y, and z onto the screen. And I can accomplish that using the printf function. So I will say printf and value of x. And then now I'm going to use the /t escape sequence, which inserts a tab after the colon. And then I'm going to do a %d, which says that I'm going to print an integer. And then I'm going to use the /n escape character to create a new line. And then the second value that I need to pass to printf is the variable that whose value should be printed to the screen. So I will put in an x there. And we will do the same for y. /t for tab, %d for decimal or integer, and then we'll print y. And then to print the float value, instead of using %d, we need to use a percentage sign and then a period or a decimal point, and then the number of places we want to print after the decimal point. In this case, we want to print 1 character after the decimal point, so we will use 1, and then an f, and then the new line escape sequence, and then we want to print z. And before we can test this out, we need to return an integer because we told it we were going to return an int. So we're going to return 0 to the operating system. And let's give this a try. So we'll go cc variables .c-o variables. And then we will give this a test. As you can see, the value of x is 2, the value of y is 5, and the value of z is 2.6. Alright, so we have printed out the values of x, y, and z. We also talked about how when you declare a variable that a memory address is reserved, a space in memory is reserved, and the memory address is assigned to the variable when you declare it. And you can actually print out the memory addresses, the locations in memory where each of your variables are stored. And for now, this is just more of a curiosity thing than anything else, but this will come vitally important later on. So let's go ahead and print out the memory addresses for the variables x, y, and z. So the memory address of x, and we are going to use a %p, which stands for pointer, because we're going to display a pointer which is a memory address. And instead of just doing X here, we need to say ampersand X. And what ampersand does is, instead of returning the value of X, it returns the memory address where X is located. So let's go ahead and quickly print out the other three. Tab, pointer, %y, and do the same for z. All right, so let's have a look. And as you can see, we have printed out the memory addresses for X, Y, and Z, but I forgot to include the new line characters. The new line escape codes. So let's try that one more time. This should look nicer this time. As you can see, we have the values of X, Y, and Z, and then we have three memory addresses, one for X, Y, and Z. And the memory address looks a bit strange, perhaps, and that's because it is a number that's in hexadecimal format, or base 16. And that's something that we will talk about later as well. Another thing that you'll notice is that every time we run this program, the memory addresses that get allocated for X, Y, and Z are different. So if you look at the numbers here, here, and here, they're all different because the system, the operating system, allocated different memory to that variable each time the program was ran. And then lastly, let's take a look at input. So let's ask the user for a number to add to the number 5, and then we'll print the result. So I'm going to first create a prompt for the user, and we'll say enter number to add to 5. And since we didn't put a new line character there at the end, the cursor for the input for the user will be after the colon. Now we want to receive input from the user so we can get the value for that integer to add to 5. And we do that with the scanf function. And scanf takes two parameters. The first one is the format of the data that it should expect to receive. In this case, we're going to expect an integer. And you will also use the ampersand to specify the location that you want to save the value retrieved from the user. So we're going to use ampersand A because we want this value that the user enters to be stored at the address of A, or the address that stores the value of A, because we want to change the value of A. So now that we have received the input from the user, we can use the integer variable B to store the result of a new calculation. So we will say B equals A plus 5. So this is just a simple mathematical expression. So the value of A plus 5 is computed, and the sum of that value is stored in B. You can also do subtraction, multiplication, division, and other mathematical operations as well. We're just using addition here for the time being. And then if we want to print the result, we can say printf. And we're going to say %d plus 5 equals %d. And then we're going to use a new line character. And as if you notice, previously when we would use the %d to act as a placeholder for an integer on lines 13, 14, and we used %f on 15, but we only used one %d or %f or %p because we only needed a placeholder for one value. In this case, we want to print the value of b, and we also want to print the sum, and we also want to print the value that the user entered initially. And so this actually works from left to right. So the first %d will be the first value that we specify here. So we want to say a plus 5 equals b. So the first value here will be a. And the second value is what's going to be entered in the placeholder, the second placeholder, and then we want that to be b. Space it out to look a little nicer here. Always remember to terminate your lines with a semicolon. And we will save, compile, and run. So enter a number to add to 5. Let's just choose 3. And yes, 3 plus 5 does indeed equal 8. I bet many of you are wondering by now why we haven't really covered strings in this lesson. In most programming languages, that's one of the first things you work with. But strings in C are not so straightforward. There's actually no such type in C as string. Only character arrays and char pointers. And the way you manipulate them in C is far from intuitive for a new programmer. This is why I've only glossed over strings in this lesson. It'll be a few weeks before we truly dive into strings, but I'll cover the bare minimum in the next lesson just to get you started in the meantime. Don't forget, you can always grab the source code for these lessons using the Git utility. You can use the command on your screen to pull down the latest source code to the current location. If you already cloned the repository, you can simply go to that same directory and use the command git pull, and it will download any changes. So before we go, it's time for our homework assignment. This week's assignment is write a small program that displays prompts to the users accepting 2 integers. Print output showing the results of adding, subtracting, multiplying, and dividing these integers. We'll cover a possible solution to this assignment before the next lesson. So that wraps up the second lesson of our C programming tutorial series. If you have any questions or comments, please post them below. I'll do my best to help. If you enjoyed this video and found it useful, please like and subscribe. We'll be back next week for part 3 of the GNU C Linux tutorial series. So hit the notification bell if you'd like to be notified when new tutorials are released. Thanks so much for watching. Please join us next week when we'll take the next step in our journey to become a competent C programmer. See you there.